Welcome in Core. There are many types of aircraft wings aside from the current ones you are familiar with. Well, maybe not the Star Wars X-Wing fighter, not yet anyway. Some of these concept wing jets are so bizarre that you'll wonder how they even got into the air. Check out the Grumman X-29 with its forward-swept wing and canard control surfaces, which some would call a bold innovation, if these can be called that at all. It was created during the height of the Cold War by the Men in Black of the Defense Advanced Research Projects Agency, or DARPA for short. NASA was also in on the game with the U.S. Air Force, along with the aerospace behemoth Grumman. It made its first flight in 1984 as part of a program to build the ultimate fighter jet. It is the most aerodynamically unstable aircraft ever built. In fact, it was literally impossible to fly this aircraft without a digital flight computer on board making corrections to the flight path 40 times per second. The engineers of the aircraft all came to the conclusion that if all three redundant flight computers, backed up by three analog computers, failed, the airplane would have broken up around the pilot before they had a chance to eject. Right now, some of you might be thinking, who told that guy to put the wings on backward? But they probably got the idea from the old German bomber Junkers Ju-287, which was actually a successful prototype when it first flew in 1944. The X-29 is powered by a General Electric F404 turbofan that produces 16,000 pounds-feet of thrust force, and the plane can reach a top speed of Mach 1.8, or 1,381.08 miles per hour. But that isn't the only forward-swept wing plane that has been designed. The Sukhoi Su-47 Burkut was an experimental supersonic jet fighter developed by Sukhoi in the early 1990s. The interesting thing about this airplane is that the wing design gave the aircraft excellent agility and maneuverability, but the aircraft never made it into production. The only one that was built served as a demonstrator for a number of advanced technologies that were actually used in fourth-generation fighters like the Su-35BM and even the current fifth-generation fighter, the Sukhoi Su-15. It was originally known as the S-37 until it became the test aircraft in 2002. It has a tandem triple layout with canards ahead of the wings and tailplanes. There are also two tail booms of unequal length outboard of the exhaust nozzles, an interesting design. The shorter boom on the left houses rear-facing radar, and the longer boom houses a brake parachute. The Su-47 can move at subsonic speeds with extremely high agility, which enables a fighter to alter its angle of attack and its flight path quickly while keeping maneuverability in supersonic flight. However, the forward-swept wings produce wing twisting as they bend under the load, which results in greater stress on them. That said, the wing has to be designed to twist as it bends, and this can be achieved by using composite wing skins. Powered by 2D30F11 turbojet engines, the Sukhoi Su-47 has a top speed of Mach 1.6, just a bit slower than the previous X-29. With forward-swept jets having some good characteristics, maybe the United States will create a crazy-looking design like this one that will give the Sukhoi Su-15 a run for its money. We touched a little on some older German aircraft, but there's another one that had some innovative wing design for its time. The Messerschmitt P.1101 was a single-seat, single-jet fighter project conceived during World War II in response to a July 15, 1944, emergency fighter program, which was supposed to produce second-generation jet fighters for the German Army. Its biggest feature was that the sweep angle of the wings could be changed before flight. This feature later developed into the variable sweep wing design that is on aircraft such as the Bell X-5 and the Grumman XF-10F Jaguar. The wings could be adjusted from 30 to 45 degrees, but were originally for testing purposes only and not intended as an operational feature. It was to be armed with 2 or 4 30 million Malawian Quachars 108 cannons, or it could also carry 4 air-to-air missiles at the same time. The first design was powered by a Heinkel Hess 011 turbojet and was the shortest of all versions, with a blunt nose and a V-tail, and it was armed with 2 108 Malawian Quachars cannons. Eventually, there were 6 different designs, ranging from single-seat jet fighters to a 2-seat V-tailed heavy fighter. The last version of the plane was a 2-seat attack destroyer, all-metal aircraft, which was powered by 4 Heinkel turbojets. The front end of the fuselage was armed with a 7.5 cm Pak 400 cannon and 112 Malawian Quachars 55 mm autocannon. But all of us know what happened next. The war ended, and so did research and development on this strange winged aircraft. Even though it never got a chance to test its variable wings, there were other aircraft that would use the same design. The General Dynamics F-111 Aardvark was a low-altitude strike aircraft which was built over competing U.S. Air Force and U.S. Navy requirements. In the 60s, the United States realized that Russia could reach its high-altitude bombers with radar-guided surface-to-air missiles like the Soviet SA-2. So a new bomber was designed that was smaller, supersonic, and could go long-range and skim close to the ground, avoiding radar systems. During the same time, the U.S. Navy was also looking for an interceptor that could be based on a carrier and armed with air-to-air missiles that could take out Soviet bombers from a distance. But all those requirements take an aircraft with a special design. The F-111 was built around two powerful, fuel-efficient Pratt & Whitney TF-30 turbofan engines that had new afterburner technology. The fuselage could hold bomb loads of up to 31,000 pounds and enough fuel to fly for 2,500 miles. Also, an extra fuel tank gave it another 1,000 miles. The challenge was having an aircraft that could fly at very high speeds but still take off from a carrier or short runway. Smaller wings create less drag and allow the aircraft to fly faster, but they also create less lift and the aircraft needs higher speeds to take off. To fix this problem, the designers adopted variable geometry or swing wings that could swing out during takeoff, allowing the aircraft to generate maximum lift, and then they would tuck inward after the plane was in the air to achieve higher speeds. Problem solved. The F-111 was the first of several major designs that used this wing technology. The Dassault Mirage G was a French two-seat, twin-jet engine concept fighter that had the variable wing geometry just like the F-111. The first prototype was built by Dassault Aviation in the late 1960s, and it was developed into the twin-engine Mirage G4 and G8 variants. The aircraft was also designed as something that could be used on land as well as on an aircraft carrier. With its variable sweep wing style, the jet fighter could be used for both interception and nuclear strike missions, and they could be launched from anywhere, even at sea. The first of these aircraft emerged as a two-seat Mirage G fighter in 1967, which was a swing-wing version of the Mirage F2. The wings were swept at 22 degrees when fully forward, and they could swing fully aft at 70 degrees. The Mirage G8, which was the last of this experimental craft, was powered by two Snecma Aton 9K50 afterburning turbojet engines that delivered 11,000 pounds of thrust and 15,800 pounds of thrust with the afterburner. The plane also featured full-span double-slotted trailing edge flaps and two-position leading edge flaps. Flight trials for this aircraft were said to be successful, but there was no production order, and eventually the program was cancelled in 1968 due to loss of funding. There were a lot of unusual wing designs that were being tested during the late 70s and early 80s. One of these crafts was the NASA AD-1, which is also the name of the flight test program. The NASA Dreeden Flight Research Center in Edgewood, California, came up with an unusual design called an oblique wing, which was fixed on a small subsonic jet-powered research aircraft called the AD-1 for the Ames Dreeden-1. This plane was flown almost 80 times and was evaluating a basic pivot wing concept while gathering information on handling qualities and aerodynamics at different speeds and different angles of wing pivot. Basically, as a craft is flying, its wing can pivot up to 60 degrees to the aircraft fuselage for better high-speed performance. While testing this design, they found different angles greatly reduced drag, and the aircraft could go faster and even fly longer range with the same amount of fuel. At lower speeds, the wing is in a conventional position, which provides max lift and better control. As the AD-1 gained speed, the wing pivots to increase this oblique angle. The whole aircraft cost about $240,000 and was powered by two small microturbo TRS-18-046 turbojet engines that produce about 220 pounds of thrust at sea level. The aircraft was limited to speeds of just 170 miles per hour because of safety reasons, and the program was retired in 1982. We're guessing you're wondering when we would get to the flying wing concept. Well, we've arrived. Flying wing aircraft are identified by the lack of a true tail section and also a lack of vertical surfaces, and the wings usually blend into the fuselage. Flying wings exhibit longer operating ranges, stronger handling, and can carry more fuel and weapons. Some concepts go clear back to 1943. The Northrop YB-49 was a jet-powered heavy bomber that was developed shortly after World War II for use in the U.S. Air Force and was a turbojet-powered flying wing. The interesting thing is that it never entered production, and a conventional aircraft was used in its place, the Convair B-36. Of course, the research that was gained from this program will be valuable to Northrop decades later when computers would advance enough in the development of the United States B-2 stealth bomber that entered service back in the 1990s. When the first YB-49 first took flight on October 22, 1947, it proved promising, and the aircraft actually set an unofficial endurance record for staying above 40,000 feet for 6.5 hours. The second YB-49 was lost on June 5, 1948, along with its crew when it suffered a structural failure, and both outer wing sections detached from the center section. The scary thing about this design is that the YB-49 would get a rapid speed increase in any type of dive, and the aircraft would rotate backward in a stall. But Jack Northrop said it was impossible with an all-wing design. More problems would show themselves, as this was an invention that was ahead of its time. But as many of you probably know, during flight tests, something else was noticed that surprised many designers, and that was that the flying wing had a really small radar cross-section. This is where today's B-2 Spirit got its design from. Powered by up to 8 Allison J35A15 turbojets, the YB-49 was very fast, and on February 9, 1949, it flew clear across the whole country from the Muroc Air Force Base in California to Andrews Air Force Base near Washington, D.C., in just 4 hours and 25 minutes. The interesting thing is that the program seemed to be plagued with industrial sabotage, and the last operational prototype was destroyed on March 15, 1950, during high-speed taxi trials when the nose wheel of the aircraft collapsed. The plane caught fire and was a total loss. We hope you enjoyed this video. What do you think the future holds for aircraft? Let us know in the comments. And if you liked the video and don't want to miss out, then click subscribe and turn on notifications so you'll be the first to know when a new video comes out. Thanks for watching Dark Core.